Vivid Audio is primarily an engineering-led company. We don't make statements in industrial design, but they are statements in acoustic design. We like to believe that we produce loudspeakers which are as free as possible from what I would dub a sonic signature, and that it's quite possible that when some people first hear a Vivid Audio product, they actually think that something's missing. Well, that's actually true. Something is missing. That's a mid-range coloration that they've probably become used to. Vivid's origins go back really to the period immediately following the creation of the Nautilus loudspeaker. So I spent some time working on magnet design using finite element analysis, and we ended up with a set of drivers which really were appreciably better in performance terms, but at that time I really intended to put them into a studio monitor. I was put in touch with Philip Guttentag in South Africa. Now Philip and a friend of his were interested in starting a domestic loudspeaker company and really had very similar philosophies in terms of what they felt to be an ideal loudspeaker. It was only natural that we should work together. The B1 was to be the first Vivid Audio product, and that used the exponentially tapered tube, which of course was historically well proven, but also the catenary dome with the carbon fibre hoop on the dome drivers. So in fact the drivers sat perfectly well with the intended designs that Philip had planned. And in 2006 we decided that we really needed a flagship model to go at the top of the oval range, but it was to be a four-way. And so really at that point it was carte blanche. I could really start again with the design, and I went through a few iterations. I had a bit of an obsession with symmetry, and so I started off by having an enclosure with dual spirals, and I was quite happy with that design, but we had a friend who was an architect, and he took one look at it and said, "My God, that's completely ostentatious. You cannot have something so ridiculous." Obviously I was a bit horrified, but he said, "No, seriously, acoustically, will it matter if you chop off the bottom spiral?" And I had to admit that it wouldn't. He said, "Well, there you go. That's the direction you need to go." But I did listen to quite a few different opinions, and in particular a friend of mine who's a painter, who was the first to suggest that maybe we could put a hole in the spiral at the top to give it some visual weight. The Giya has this smooth contour. Again, the cabinet just blends away from the front surface down to the side. There is no particular point at which it changes from being the horn, the front, the side or the back. It's all one continuous curve, and that means that we don't get interference which would mess up the frequency response. Newton's third law is that every action has an equal and opposite reaction, and so clearly it's the same with the loudspeaker driver. So as the cone moves forward, the magnet moves back. The actual motion of the magnet is pretty tiny, and on its own the magnet would actually radiate very, very little sound. The driver on its own doesn't make much sound, the magnet, but as soon as you couple it to the enclosure it would actually become very audible. So it's quite important that the magnet vibrations are isolated from the cabinet. A virtually perfect solution, that is to use reaction cancelling. I like to illustrate this by moving my hands. If I move them together, then you can see that my body moves quite violently in reaction, whereas if I move them in opposite phase, you can see that I remain perfectly still. The reaction force is completely removed, which means that actually the enclosure no longer needs to be heavy. Suddenly our requirements for the base enclosure material are light and stiff. Now those are requirements that you'll find in Formula One, aerospace, all that sort of high performance equipment, stuff which needs to go fast and react quickly. And the common factor in all of those is the use of stressed skin composite sandwiches. We use quadriaxial glass skins with an end grain balsa wood core, and the thing about vacuum infusion is that because the whole composite is under pressure, under compression, when the resin is actually drawn into the composite, it means that we use the absolute minimum of resin, and that's good from both an environmental point of view, of course, because we use as little as possible, but it actually means that the thing is as light as possible. And the lighter we can make the thing, the higher the resonant modes, and that's the point of the enclosure, is we're trying to keep all those structural resonant modes as far out of band as possible. And we don't launch a product simply because we feel that there's a slot in the market that needs filling. We launch it because we have made an engineering step which justifies producing a product which incorporates that. So the Giya is a perfect example. We've developed the tapered tube enhanced reflex enclosure. Now let's build a product around it, and it became the Giya. And as I said at the outset, we aim to produce the clearest possible window on the original performance, and I'd like to believe that we've achieved that.